everybody, welcome back boys and girls. It's your man Math Man Mishen coming live from Summit Academy. In this video we're closing out the unit number 5, talking about lesson number 22, and what we're going to be able to do today is we're going to try to describe how a change in the radius affects the volume. So for the first one it says any missing information. So it says cylinder and a sphere have the same height, and it says if the sphere has a volume of 36 cubic units, what is the height of the cylinder? So we're going to say for this one, I can find the volume of the sphere, and so I'm going to say that's going to be the same as 4 times pi times the radius cubed over 3, and so I could say that's the same as this 36 pi, so I'm going to say 36 pi is equal to 4 times pi times the radius cubed all over 3. And so what I can do first is I can cancel out pi on both sides, and I can multiply both sides by 3 over 4 to try to get rid of that fraction. So I'm going to multiply both sides by 3 over 4. So this is going to be equal to, or this gives, let's say this is the same as 27 is equal to r cubed. And if we're trying to find that radius, I have to get the third root. So I'm going to say take the third root of both sides. And so I'm going to say r equals 3. So if our radius is 3, what is going to be the height of the cylinder? And so we can say the height, we could say h of the cylinder is going to be 2 times the radius because they have the same height. And so we're going to say h is going to be equal to 6 units. Now for the second part, it says what is a possible volume of the cylinder? Well, if we let r equal 3 and h equal 6, we can say the volume of the cylinder is going to be equal to the area of the base times the height, which is equal to pi times the radius, which is 3. So I'm going to say 3 squared times 6. So this is going to be the same as pi times 9 times 6, which is equal to 54 pi units cubed because we're talking about volume. Moving on to the second part, it says fill in the missing volumes in terms of pi. So add 2 more radius and volume pairs of your choosing. So it gives you the first one, so it's saying if the radius is 1, again, we're still using the for the volume of a sphere, that's the same formula as before, so we're going to say that's equal to, well, we will say that's going to be 4 pi times the radius to the third power all over 3. So that's why the radius cubed isn't there, because it's 1 to the third power is 1, which is the same as leaving it like this. So if we write it for this first one, let's do it like this. Let's say this is the same as 4 times pi times 2 to the third power over 3. If we do 2 to the third power, that's the same as 8, which if we do 8 times 4, that's 32 pi. So I'm going to say 32 pi over 3. Then this is going to be the same as 4 pi times 3 to the third power over 3, which is 27. Then we do 27 divided by 3 is 9, and 9 times 4 is 36. So I say 36 pi for the volume when the radius is 3. Then if we have 1/2, we're going to say for this one, let me actually make myself some space here. So give me 1 second. I'm just going to move this down a little bit. Let's do like here. So I'm going to say this is the same as if I say 4 pi times the radius, which is 1/2 to the third power over 3. So what I can do is I can write these values. So this is the same as 4 pi times 1 over 8 times 3. So if I would rewrite this and simplify, it would be the same as pi over 6. So make sure you're careful. Again, I'd be doing 1/8 times 4 is 1/2, which is the same as 1/6 because I have that divide by 3 there. And separately, for this one, same kind of idea. I'm going to say I have 4 pi times 1/3 to the third power over 3, which is the same as 4 pi times 1/27 divided by 3. Since I can't simplify that too much, I'm just going to say for this one, it's going to be, what do I have here? I have 4 pi over 81, since 3 times 27 is 81. For this one, it's going to be a big number because we have this is going to be the same as 4 pi times 100 to the third power. So this is going to be a big number, so it's going to be, I think, 4 million. So 1, 2, 3, 4, 5, 6 times pi and over 3. So now for these two, try your turn. Try picking a radius r and have your volume. So all you really have to do is have radius to the third power times 4 pi over 3, which is what we have for that last one. So this is going to be the normal formula: 4 times pi times radius cubed, e to the third power, all over 3. Then for the next part, it says this. It says, how does the volume of a sphere with a radius of 2 compare to the volume of a sphere with a radius of 1 centimeter? All right, so what we can say is this. We can say the volume of a sphere with radius 2 is 8 times as large as the volume of a sphere with radius 1. And we know that because 2 to the third power is equal to 8. And for the second part, it says, how does the volume of a sphere with a radius of 1/2 compare to the volume of a sphere with a radius of 1? And we can say this. We can say the volume of that sphere with a radius 1/2 is 1/8 as large as the volume of a sphere with radius 1, since 1/2 to the third power is the same as 1/8. So just make sure that you're multiplying those carefully. Moving on to the next part, it says a sphere with a radius has a radius of length r. And it says what happens when the radius is doubled. So that just means when we double the radius is double, it's almost like we're saying 2r. And so what we can say is we can plug that into our formula. So we have volume is equal to 4 times pi times the radius, which is 2r to the third power, all over 3. So if we simplify that out, it's going to be 4 pi times 8r to the third power over 3, which is the same as 32 pi r to the third power over 3. Remember, this is 8 times as large as the original. And for the next one, it says what happens when it's halved. So that just means we take r over 2. So we have the volume is equal to 4 times pi r over 2 to the third power, all over 3. Be able to simplify that out. So we have 4 pi times r to the over 8, all over 3, which is the same as saying pi times r to the third power over 6, similar to what we had from before. So that means it's 1/8 of the original. All right. Then moving on to the last one on the front side, it says a sphere Q has a volume of 500 centimeters cubed. A sphere S has the radius of 1/5 as large as sphere Q. What is the volume of sphere S? So what we have to remember is this. We have to say, well, the volume will be 1/5 to the third power as large as sphere Q. So what we can do is we can say, well, on the side here, let me do 1/5 to the third power is equal to 1 over 125. So what we can do is we can take that amount, and so I'm going to say I have 1 over 125 times, our original amount, which was 500. So when I multiply that out, I'm going to say that's the same as 4 centimeters cubed, which is the volume of sphere S. Man, let's try that again. There we go. Moving to the back, some review problems that we had. It says Jada is 3 years older than twice her brother's age. Select all equations that correctly represent the relationship between Jada's age and her brother's age. So we're going to say for that first one, again, it says twice her brother's age plus 3. So that's going to be that first one, A. So that A is good on that first one. And the only other one is if we were to rewrite it, we could say E is going to be the last one that works out, because if we were to rewrite it, if this would be solved for B. So it's just rewriting that equation for that situation. For the second part, it says select all proportional relationships, and just remember, what does it mean to have proportional? That just means it goes through the point, 0, 0. So all we have to do is pick the ones that go through the point 0, 0. So we know it's not going to be this first one because it does not go through that point. How about the second one? It says a train traveling at a constant speed of 60 miles per hour. And then it says the number of hours the train has been traveling T hours. The number of miles the train has traveled is D. So we could say, hey, that's going to work out because if we plugged in the point 0, 0, it would be it has traveled 0 miles. So that if we wanted to write the equation for that, it'd be D equals 60 times T, where T is the number of hours and D is the number of miles. For this one, if we find the slope, so let's find slope. So again, slope is equal to change in y over the change in x. So if we find the change in y, that's going to be plus 6, and that's going to be plus 1. So that's our slope. So we could say slope is going to be equal to 6 over 1, which is just 6. So if we were to come up with that, what would be that y-intercept? Because that y-intercept has to be 0. And so if we backtrack, we can say it goes to the point. So it's almost like we go up the ladder. So if we had the point 3, 6, we can go up. We say we have minus 6 and minus 1 to go in reverse. So our next point is going to be 2, 0. Our next point after that is going to be 1, negative 6. And we have the point 0, negative 12, which is not the point 0, 0. So we're going to say this one does not work out, since our y-intercept is not 0. So these two have to match up, which they do not. However, for the next one, it says y equals 3x, where x and y are both positive numbers. This one's going to be good because it goes to that point 0, 0. So this one is good. However, for that last one, we can't divide by 0. So I'm going to say this one is not good because function, we could say our function is undefined at x equals 0. So because of that, we cannot include it. So it's only these two options. Moving to number 3, it says there are 16 cups in a gallon. The equation G equals 1 over 16 times C gives the number of gallons in terms of the number of cups. Write another equation for this situation, giving the number of cups in terms of gallons. So if we start with, and we have to have C equal. So if we start with G equals 1 over, or C over 16, we have to solve for C. So it's real simple. One step equation gets C by itself. So if we multiply both sides by 16, we end up with our equation. So we're going to say C equals 16G. So again, solve for C means get C by itself. Moving on to number 4, it says when x is equal to 1, what is the value of y, that makes the equation true. So all we have to do is plug it into our original equation. So we're going to say y equals -3 times 1 plus 2.5, which is equal to, this is going to be -3 plus 2.5, which is going to be -0.5. Now it says when x is equal to -1.5, what's the value of y? So same setup, however, change that value of x. So we're going to say y equals -3 times -1.5 plus 2.5. So this is going to be the same as y equals 4.5 plus 2.5. And so for this one, I'm going to say y equals 7. And lastly, now we set it up when y equals 8.5. So we're going to say 8.5 equals -3x plus 2.5. So I'm going to subtract first to try to get that variable term by itself. Subtract -2.5 from both sides. Left side is just 6. Right side is just -3x. Divide both sides by the coefficient to get x by itself. So we divide both sides by -3. And we say x is going to be equal to -2. Moving on to number 5, some rectangular prisms. Go back to 7th grade and make sure you can figure out how to do this. But we're going to say, okay, if these are the dimensions, again, I can label them like this. I can say if I have the length is going to be L, the width is going to be W, and H is going to be the height. So I'm going to say the length is 8, the width is 1.5, and the height is 2.4. So all I have to do for that surface area of a prism, I'm going to have, it's almost like I'm taking 2 times each of these. So I'm going to say the amount is going to be 2 times 8 times 1.5, plus I have 2 times 8 times 2.4, and lastly, I have 2 times 1.5 times 2.4. So altogether, if I was to calculate that, I would end up with 69.6 inches squared, since we are talking about an area amount. And lastly, for that volume, again, remember, it's just that the volume of the prism is those 3 dimensions multiplied together. So I can say I have 8 times 1.5 times 2.4. Altogether, that volume is going to be 28.8 inches cubed. And for this last one, it says a circular field has an area of 14,400 pi square feet. So remember, when we're talking about a circular field, that's just talking about the area of the base is going to be equal to pi times the radius squared. So that's that area of that circle that we've been working through without the unit. So that means I can write it like this. I can say I have 14400 times pi, and we're going to say that's equal to our right side when we find the radius. So I can cancel pi out from both sides. Let me try doing a red. I guess that's red. So we're going to say to get r by itself, we have to take that square root. I'm going to take a square root of both sides, and I can say r equals square root of 14,400, which is just going to be 120. And let me say feet for that. All right. Then what's the diameter of the field? Well, we can say diameter is equal to 2 times the radius. So we're going to say 2 times 120. So let me make it a little bit smaller. 2 times 120, which is, we can say d is going to be equal to 240 feet. And for circumference, make sure you remember that's going to be, we can write it like this. We can say our circumference is equal to pi times the diameter. So we're going to do 3.14 times 240. Make sure you round to the nearest whole number. So we're going to say our circumference is going to be equal to 754 feet. And so that's just going to be the outside amount. Be sure to pause, rewind, or replay as needed. Ask questions as they come up. And as always, super slam that subscribe button.